Today we'll be talking about chapter 12, which is all about physical properties of matter. So the first physical property that we want to understand is the different states of matter. So we have solids, liquids, and gases. So a solid is when a substance can hold its own shape. It doesn't need a container to keep its shape. It doesn't compress, so it has a fixed volume, and it can support forces that are exerted against it. A liquid is a substance that changes its shape depending on its container, and it still has a fixed volume though. So 1 liter in a certain vase will be 1 liter still if you pour it into a bucket. And then we've got gases, which have variable volumes depending on their container, and they change their shape depending on their container as well. So that's physical states of matter. So there are 3 different kinds of forces: shear forces, compression forces, and tension forces. And shear forces are when it's like a tearing motion, or when there's forces going like this to each other. A compression force is when there's forces going inward, compressing something, and tension forces are forces going away from each other, so like pulling on a string. Okay, so solids can support all 3 of these forces. Liquids, however, can't support shear forces. Like if you imagine trying to tear water, that doesn't really make sense. If you're in a pool, you can't tear any of that water. And then gases can't support shear forces or tension forces. You can't pull a gas apart. And that might seem weird for a liquid as well, but if you think about sucking a liquid up a straw, it resists that upward motion, and so that would be a type of tension force in a liquid. So just to recap, solids have all 3 forces, liquids support compression and tension, and gases support only compression forces. So those are macroscopic forces. It's also important to understand the forces within substances. So the stronger the forces that are holding a substance together, the higher the melting point is going to be. So I've written up this table here, and we can see that from the top, hydrogen has a low melting point and a low boiling point. So that tells us that the forces holding hydrogen together are pretty weak because it doesn't take that much energy to break hydrogen apart. Then as we go down the table, ethanol has a melting point of -117 and a boiling point of 78. So as the melting point increases, so does the boiling point. And as we go down the table, we can see that as the melting point and boiling point increase, so does the disparity between them. So once we get down to magnesium oxide, here's its melting point, and we can predict its boiling point based on this trend that we've seen. So if we look at these 4 numbers that I've written up here, we know that as melting point increases, so does boiling point. So we can automatically eliminate 400 and 2300 because those are lower than this. And then we know that it's probably going to be 3600 because this is only 70 degrees away from this. And we know that the disparity between them, or the difference between them, gets greater as the melting point gets greater. So 3600 degrees is the melting point of magnesium oxide. The next physical properties that we want to talk about are the electromagnetic spectrum. So I've written up the electromagnetic spectrum right here. So what the electromagnetic spectrum is, it's basically color. We can only see photons that are in the visible spectrum, and these are the colors that our eyes can see. But some animals, like snakes, for example, can see in the infrared spectrum where we can't see. And so the spectrum is based on wavelength, which is the point from any 2 similar points of a wave, like from the crest to the crest, which is also the same thing as frequency. So the bigger the wavelength, the lower the frequency, okay? So high frequency electromagnetic waves, the highest are gamma, then we've got X-ray, UV, visible, infrared, micro, and radio waves. And so a way to help you, a little mnemonic to help you remember this, is grandma examines ultra vacuums in my room. Or another one, going the reverse way, is rabbits mate in very unusual extreme gardens. So whichever one helps you remember it, you need to know that electromagnetic spectrum, okay? When we see something, what we're really seeing is the photons that are reflected from that substance. So say we have a tree that's green. That means that all of the photons are being absorbed by that tree, except for green photons, which are bouncing off of the tree and going into our eyes. So say we have a tree that's in a full visible spectrum of all the visible electromagnetic photons from red to violet, we're going to see green. If we saw just green light shine on the tree, we'd see the tree as green. But if we saw red light shine on the tree is going to absorb that red light, and it's not going to have any green light to reflect. So we'd see the tree as black, okay? So we see the color that's reflected. And then sometimes if we heat a substance up to become a plasma, then it will emit light. So if it emits a continuous spectrum, which is like a rainbow, that's just a complete rainbow. Sorry, it's in chalk. But imagine this is a rainbow. This is a continuous spectrum. So that's like the sun. The sun emits a continuous spectrum. If it emits a discrete spectrum, that would be like hydrogen when we heat it up, where it only emits maybe this color and this color and this color. That is a discrete spectrum. And so that's when something only emits a few colors. The last thing moving on from color is conductors. So all you need to know about conductors is that a conductor is something that carries a charge or allows a charge to move through it. Metals are conductors when they're solid, and then we also have something called an ionic conductor, which it can conduct electricity when it's either melted or dissolved. So that would be like salt. Salt is not a conductor when it's a solid, but if you dissolve it in water, it becomes a conductor. So that's an ionic conductor. And that is what you need to know for chapter 12.